so that they can listen to the recording afterwards. So I hope that you are all fine with that. All right, so I bid you a very warm welcome, everyone, to this afternoon's webinar from a chilly Cape Town, where winter is just not wanting to leave us. It's another cold winter's day here, and I hope that it's fine, that the weather is better wherever you are. So I'm glad to see so many of you in the online audience, and I am aware that all of us have such busy diaries and schedules, and we are all under pressure to try and squeeze in everything that needs to be done. And that is why I am so especially grateful and glad that you set aside some time this afternoon to join this webinar. I'm just going to try and see if I can find the chat. There we go. We have the chat. All right. So this webinar is hosted by the HELTASA Professional Learning Project team. If you would like to learn more about the HELTASA organization and specifically the Professional Learning Project team, you are welcome to do so by following the link, which I will post in the chat later on after the welcome, where you can read more about what it is that the Professional Learning Project team is all about. The Professional Learning Project team of HELTASA currently consists of 5 members. Some members can unfortunately not make it this afternoon because of other commitments. I do, however, have the support from my fellow team member, Professor Muhammad Nakuda, and I saw him previously in the audience from the Cape Peninsula University of Technology, and he will be helping to managing the chat this afternoon. Thank you so much, Muhammad, for your support and for being here. I also notice a few familiar HELTASA faces in the audience. Thank you for being here and a warm welcome to one and all. So without further ado, I would like to introduce our speaker this afternoon. She is Dr. Hannelie Ardendorf, whom I have the privilege of calling my colleague. Dr. Ardendorf is a senior advisor in higher education, teaching, learning, and assessment at the Stellenbosch University for Center for Teaching and Learning. She holds a PhD in chemistry, but she has been working in professional development since 2002. She has worked in the areas of science education, facilitation of collaborative learning, the decolonization of the science curriculum, assessment, and more recently, the impact of AI on higher education. And I know that she's been working very hard to get some guidelines for our institution in place with regards to that. But today, she will be talking about teaching practices that could support student learning. Thank you so very much, Hanli, for agreeing to talk to all of us about this topic. So, colleagues, let's welcome Hanli by a show of hand claps. You can use your reaction icon. And Hanli, I am now going to hand over to you. Thanks again for being willing to present this webinar this afternoon. Over to you, Hanli.
Hi, Anthea and everybody else. Thank you so much for the warm welcome, Anthea. It is a pleasure to be here this afternoon. I hope I can share something that will be of value to some of you. I'm just going to take a second to get the PowerPoint up and running. Teams always has a mind of its own. So it should hopefully be there in a moment or two. Can I just check that you can hear me fine as a first step?
Can hear you perfectly well, Hanli, and I can also see your presentation now.
Fantastic. Thank you, Anthea. So here we go. All right. So tools for understanding teaching. What I'm going to try and do in the next half an hour or so this afternoon is to present a case for why it would be useful for us to have tools that can help us make sense of teaching and teaching experiences, by demonstrating one such tool. So the one such tool that I will be demonstrating is LCT for short, or legitimation code theory for people that are more familiar with it. And just before I get started with that, I'm also going to put up an advert by request of the organizers of the LCT conference. The 5th LCT conference will be held in Johannesburg at the WITS LCT hub early next year. The LCT conference is usually a lovely, vibrant experience. So if you're already working in LCT, or you consider working in it, or you're just interested in it, or you might become interested in it this afternoon, although this is not intended, the presentation is not intended firstly as an advert for LCT, it's just the example. Consider the LCT conference, the website's URLs also on that slide, and you can also join the mailing list. LCT is quite an active community where there's a lot of support. All right, but to get started, I'm going to ask you just to indicate for me, I'll drop a poll in the chat, how familiar you are with LCT, so that I have an understanding or an idea of who the people in the audience are. Now, unfortunately, there's not that much. I'm going to be able to change in the presentation based on what you tell me. Other than it possibly raising my anxiety level, if you all tell me that you're experts already, then maybe I should sit back and have you talk to me, or analyze what I'm presenting to you. All right, so it seems at this point in time, by the information coming in, that we are more sitting on the novice to about it levels. That's that's more or less where I will pitch the presentation this afternoon. The idea is to try and show you what this tool can do without going into the detail of the tool. All right, so to get started then with the presentation, I'm going to ask you to pretend with me for a moment. Let's pretend you're a first-year student in chemistry, in science, and you're taking chemistry as a module. That's what I did, as Anthea has shared, before I started working in the field I'm working in now. Now, what you have on the screen is a fairly typical page from a chemistry textbook, excluding possibly the cell phone image, which is just there to make it a bit more interesting. What we have on this fairly typical chemistry page is some information about acids and bases, and specifically the definitions of a Bronsted-Lowry acid and a Bronsted-Lowry base, and then the generalized reaction formula for an acid-base reaction in chemistry, where we have the acid depicted as HA and the base depicted as B, as well as the conjugate acid-base pair. Now, I, of course, love acid-base chemistry, love teaching this. I think it's a beautiful application of chemical equilibria, which also draws on an understanding of chemical reactivity and sometimes on stoichiometry. And I love playing with it. But our chemistry students don't always feel the same, and this is often quite evident when we assess them on this topic. Now, what I want to ask you next is, it's maybe a slightly unfair question because you've not had much time to consider what's on the screen. Maybe some of you do have extensive background in chemistry, but what do you think might be leading to the fact that our students often struggle with this? Just looking at the screen, first thoughts, and there are no right and wrong answers here. So that's the good news, unlike chemistry, which typically have right and wrong answers. What might be contributing factors to students struggling with the information that we have on the screen? And this is a lovely new tool I found in Teams. I didn't know until this weekend passed that Teams allowed us the option of a Wordle. I learned when I trialed this previously that as the information increases, you'll later see as normal Wordles go, it shows you bigger words means more people have entered that in their answer. And you can actually hover over it and see how many people use that specific word in their answer. So lots of very useful, very interesting information coming through here. I just love doing this, Anthea. I trialed this same presentation on Tuesday on my campus, and I love seeing prior knowledge coming up here now and on Tuesday. That's interesting background information. Terminology is a big one. Application from theory is another big one. Important, yes. Language barrier. Jargon, yes. Ability to comprehend content, equations. Don't you just love equations? They're so beautiful. And you just need a few letters to tell a whole story, right? All right. I'm not going to respond to that straight away, but I will come back to this example and to what you posted there. I want to move on to something that is, I already put that question up, to something that is maybe a little closer to home for some of us. So more recently, what I would more often talk about is, or teach, is how to do research in the area of teaching and learning, where I work with academics and workshops. And inevitably, words like epistemology, ontology, axiology, and methodology would come up in those conversations. Now, these participants don't look at me blankly like chemistry students would, but they do make their dismay known through stares and frowns and lots of questions, quite often to continue explaining statements like the one on the screen. So example here is, in research, we inevitably bring our epistemology to bear on our data through our theoretical frames. Our epistemic beliefs thus inform and underpin our methodological and theoretical decisions. And I promise I won't ask you to complete something every minute, but I do love to have a bit of interaction with the audience. So what I actually want to ask you to do next is give me an indication of how you feel when you see this statement. Are you in that category of people that get very, very excited because this is just the language you love to talk? Or are you in the category, and I have colleagues like that who just close their eyes when they see a statement like that? And actually, I also get that quite often with my science participants in presentations. So where do you fall? Quite happy with it? You feel calm, it makes a lot of sense, or are you on the side of not being, would rather not want it? All right, let's see what's happening there. It's interesting, sometimes teams want me to complete the poll as well before it will show me the results. Okay, so we're sitting sort of lower down the middle. Not so happy with it. All right, so this is good then. We're going to unpack it a little bit. So let's look at this statement. The issue here is accessing the discourse. And this was my last work for the better part of a decade. After I left chemistry to join the Center for Teaching and Learning, I struggled to access the discourse in higher education, conferences, etc. And it was ironically at one of the very first HELTASA conferences that I attended. I think it was Lynn Quinn who helped me understand this when she pointed out to me that the difficulty I had in making sense of this language on the screen could be related to the difficulty my chemistry students had in making sense of what you'd seen on a screen or two ago when I shared that example from a chemistry textbook. All right, so if we look at the specific statement, we've got quite a few really difficult words in the statement: epistemology, theoretical frames or frameworks, epistemic beliefs, methodological and theoretical decisions. So lots of words that make us stop. The previous chemistry example, if I could refer to that for a moment, you know, when I was a chemistry lecturer, I would not have thought twice about many of the words on the screen. And actually, when I put it together for this presentation, for the first time, I found myself halting at some of the words, like Bronsted-Lowry acid or Bronsted-Lowry base, or whichever way around it goes. For the first time when I saw that, my mind stopped and went, if they named that acid and base, then there must be more. Are these what? And for the first time, I think I understood something of what might be going through a student's mind, and possibly because years of trying to make sense of this kind of language we have on the screen has changed how I reflect on my own interaction with the text, with what's on the screen. And now I understand how just that one term without explanation could throw students. All right, so let's see what we can do with these terms. And this is where LCT then comes in and becomes really useful. LCT is called many things, but I like to think of it in terms of it being an analytical framework or toolkit with multiple tools in it that can help shed light on different aspects of all sorts of things, not only teaching and learning, but especially helpful in the teaching and learning context. One of those tools in the LCT toolkit is a tool with at least two parts called semantics. And one of those parts in the semantics tool is called semantic density. And as you might expect, semantic density refers to how densely packed the thing I'm dealing with is. Right now, I've got a word up on the screen or a concept, epistemology, but it could also be an image. It could be a piece of code, I guess, or all sorts of other things we're looking at. What we want to know is how much information is packed into that thing. And there can be different kinds of information packed into my understanding of a word such as epistemology. Some of it is purely, let's call it theoretical. It's what we would call epistemic. It's explanatory, it explains it. But some of it might be more emotive or value-based, what we'd call axiological density packed into that specific term. So in the case of epistemology specifically, you could possibly add a lot more words. But if you just Google and you ask Google, what's epistemology? Trust me, I've done it many times in my life. Lots of things will come up, from it's about how we can know, to what can we know, to what is knowledge. It has something in it about our assumptions, something about beliefs. The other day I found a definition that says it's our justified true beliefs. There's something about truth then in it. Reason, justification. But many of those words themselves are quite densely packed, aren't they? They've got lots of meaning packed into each one of them as well. The thing here is, if when I speak to academics about this word epistemology, or when academics, let me start that way around, read that piece of text I had on the screen just moments ago, they have to figure out which of these meanings they have to bring into their understanding of what's on the screen. Is this piece of text here now about truth or belief, or about how can we know, etc.? So semantic density then helps me understand that if I want the people in my audience to better understand what I'm talking about when I use the word epistemology in my sentences, I have to unpack it for them. I have to help them see what meaning am I drawing on packed into that term when I'm using that term in my conversation. But semantic density is not the only element of semantics that is useful here. There's also another part of semantics called semantic gravity. And semantic gravity has to do with how context bound or contextual the thing I'm dealing with is, or how abstracted. What we often do in higher education and research is we try and abstract principles from specifics, right? It's what in the chemistry example I told you, we had the generalized reaction equation for an acid-base reaction on the screen. It's generalized to the point where we have HA as referring to all acids, and there are different kinds of acids, etc. So it is the most abstracted version of referring to acid that I could possibly put up on the screen. And if I want to increase the semantic gravity, if I want to bring it closer to ground, it's not floating so high, right? Then ways we would do that in chemistry is by giving examples of specific acids, like hydrochloric acid, vinegar, the acid in your lemon juice, etc. So that would be ways of the examples of specific acids and specific kinds of acids would bring the make the semantic gravity closer to the context, bring it down, so to speak. All right, so how can we do that with epistemology? Well, one way we could do it, if I'm teaching someone on epistemology, is to say, well, this is not increasing semantic gravity. This is actually making it less dense. Epistemology for our context is about what we believe about generating knowledge, which of course, as we know, is linked to what we believe about what there is to know, but we're not interested in this right now. So now I could tell them, And this is what you'll often get on the internet. There are different kinds of epistemologies. You can hold different epistemologies, but does that help you if you don't know what epistemology is? Does it bring it, make it increase the gravity, bring it closer to context? Not yet. But if I start to show participants what this might look like in the practices they come across, then maybe it starts to make a bit more sense. So I could say, you know, if you want to see what an objectivist epistemology looks like in practice, there's a greater chance that someone, or you, if you hold that, might use observation as your means of gaining information with which you can make sense of reality or the multiple realities or whatever you might believe. And quite often in an objectivist epistemology, we will do that through designing an experiment of some kind, be that in a lab or in a social context, where we look from the outside in, we do measurements with the purpose to predict. And then I can show them that this is not always the case and that it might play out in different ways, but I can show them examples of how this might play out in practice. And I can also contrast and compare it to other ways of interacting with reality. For example, if you hold a constructionist epistemology, then maybe you're more likely to interact with the world and with trying to find information through interpretation, which might be visible in approaches such as phenomenology or maybe ethnography, where you might work more from the inside out and follow a more participative approach with a purpose of understanding. So you start to see what's happening here. So this allows me, this tool of semantics now allows me to see where it is and why it is that the people in my audience might get stuck when I teach or talk about epistemology. And there's more than one way in which we can depict or draw pictures of how semantics plays out. One of them is through the use of semantic profiles. The way that we draw this graph or profile is that right at the top, we've got that top line. That's where things are most floaty, they're in their most abstracted form. That's not necessarily meaning they're abstract. They're just in their most abstracted form, mostly looking at principles and theoretical stuff there. And it's also where they're most densely packed with information. The line right at the bottom is where things are generally more contextual. Examples, might be real life examples or lab examples, and where they're least dense, right? So what we learn from this is what we've got to be careful from what semantics help me understand in teaching my clients about, or my colleagues about epistemology, ontology, etc., is I've got to be careful not just to talk in that very theoretical speak right up there at the top, because that line at the top called A on the graph is what in LCT is called a high semantic flat line. But it's still a flat line, and a flat line is not really a good thing, right? And the one at the bottom, of course, is then a low semantic flat line. The difficulty with teaching right up there at the top is that it's very difficult for students who only get the very theoretical, abstracted, dense teaching to see how those principles apply to practice, to take that back to practical examples. The alternative is if we only teach in the context, then it's very difficult for students to see how they're going to get the principles from the more contextual, less dense teaching. So what? How have people used this? And I'm going to draw this here on science because that's where I'm more involved, was more involved with LCT work. So Stellenbosch University and beyond, Max Blackie, no longer at Stellenbosch University, used semantics to look at teaching specific difficult chemistry concepts. So focusing on concepts, a bit like what I've done here, but obviously much more theoretical and advanced. And Manuel Maton, Stellenbosch University Biology, used the same tool in the LCT toolkit to look at restructuring, redesigning biology curricula. So not just specific concepts, but biology curricula to ensure that there's adequate movement between the bottom part of that graph and the top part of the graph. And then a very different application of the same tool, Christine Steenkamp, Physics, Stellenbosch University. All this is published work. Christine used the same tool to look at physics first year assessments and to come up with a tool for standardizing physics assessments so that it would be pitched on the level at which academics are hoping to pitch the assessments. All right, moving on from that, I want to showcase two other LCT tools far more briefly. And for that, I'm going to tell you a very, very brief personal story. As you would have figured by now, I taught chemistry for quite a while, at least 7 years, and then I moved to do what I'm doing at the moment. I loved teaching chemistry. I loved interacting with the students. I never had difficulty with students misbehaving in class to any degree beyond what we would normally expect. They're students after all. And as a matter of fact, I started doing this job being asked to talk about teaching large classes, because that's what I did and that's what I loved. Then fast forward a few years, quite a few years, probably about 10 years, I went back to teach group work to natural science students. And yeah, I know, how do you teach group work? Well, we didn't teach group work, we had them do group work, but for that we taught them some principles around things like conflict management, working in a group, what kinds of things might happen, etc. However, this round, same size classes, also science students, I had incredible trouble with classroom control. And I had, obviously, as an academic, you reflect on it. So my first reflection went along the lines of this. You know what? This is a different generation of students. 10 years have passed. They're just different now. They just act this way anyway, because they talk nonstop throughout the whole lecture. They talk to the extent where some students would come and complain to me and say, we want to hear, but we can't hear a word because they're talking constantly. I tried punitive measures. I tried all sorts of things. So that was my first reflection. And that reflection was, in my mind, to some degree, justified by the fact that other more important people than I had the same problem with the same group of students in the same bigger course in which we taught all sorts of things like group work, time management, etc. Then a year or two into that, a student came to me after a lecture and said, oh, ma'am, you're a psychologist, right? They weren't going to ask a question about the content, but something completely different. And that sparked a different kind of reflection. Maybe that's it. Maybe that's why they are not paying attention during these classes. It's because they don't think I have anything to say to them, because they're scientists and I'm a psychologist, and you know that science snobbery thing going on there. So that was my second reflection. I'm going to now give you an opportunity. I'll take a brief pause from talking and ask you to tell me why you think, what might have contributed, why might I have struggled, what might have been reasons why I struggled with classroom control in this specific case. So let me take a moment and see what wisdom you all come up with, because there might be things I've not even considered yet, right? Oh yeah, that's both those are really good. It's interesting. I love doing these kinds of things. I considered a lot of what's on the screen, but the second point that went up, the instructions, I never considered that. I never thought about, maybe it's in the instructions I gave, the instructions they've been given. Yeah, you're right. I'm actually not going to use the semantic wave here, but it could have played a role. Own interest, yeah. Oh, ground rules. I tried ground rules for the group work. I never tried ground rules for my class. That's another. I did impose a heavy set of rules, which almost led to a riot, and it didn't work. The age difference probably played a role. Yeah, I was closer to their age when I was teaching chemistry. That's very true. This is so fun to see what people come up with, and yeah, amazing. Generational gap was really what went through my mind, and I'm just not getting this generation anymore. All right, so now I want to introduce you to another tool, which shed some light for me, but I didn't test it. So I'm just playing with it. This is not a study that I did, so I can't say definitively that I did anything that proves this. Okay, that I already asked. Second LCT tool I would like to introduce you to is one called specialization. And the two tools I will talk about now, both specialization and the one coming after this, both of them are interested in where legitimacy comes from. So where semantics was interested in how we make meaning and how we communicate in our disciplines, and there's some legitimacy in that as well. These are specifically focused on legitimacy, and specialization argues that my legitimacy in a knowledge practice is a mix of two things. It is what I bring, who I am, my values and my attributes, as well as what I know, what kinds of tools, theories, etc. can I handle. And different knowledge practices or different disciplines places different levels of emphasis on these two. So quite often what we find, I'm going to put it this way to be careful, quite often what we find is that in social sciences, it can be more important. Your legitimacy can come more from who you are, how you interact with theories and your critical stance, etc., than the specific theory or tools in theories that you can operate, so to speak. Whereas in science, that's less important, who you are generally. What's more important for your legitimacy, for what will make people listen to you, is whether you can prove that you can use the tough science concepts like the Schrödinger equation or acid-base theory, for example. I don't think that one has as much traction as string theory or Schrödinger equation. So science students, there's been studies like this, depending on their schooling and background, etc., done on interesting studies on this done in Australia with students coming from the East, might come into classes, and their depiction of legitimacy in those classes would be based on this understanding that I'm a scientist. I can handle these tough science concepts, and that's what makes me legitimate, not these value-based, woolly, soft skill kind of stuff that I'm coming to talk about. So I might not have been, I might have been onto something when I thought that they thinking that I am a psychologist is leading to them thinking that I'm not a legitimate teacher in a science course. I then, at some point in time, even before meeting specialization, I then reverted to quite strongly and seriously making sure that they knew that my background was in chemistry. It still didn't help, but I think there's something in specialization here in understanding that we can plot it on the quadrant. So this bottom right-hand side part of the graph, not really called a quadrant in LCT, but a code. In this area, my legitimacy comes more from who I am, as we would have in an area in some of the social sciences area, and especially in being a good person in a group work context. It's very important who I am. It's not so important whether I know all the group work theories, right? Whereas in science, it's all about what I know and the tough things I can do. So you can see that there's a disconnect then for students here, both between what I'm trying to do in group work and what's important in group work and what they perceive as important to success in their studies, which is what they're here for, even though I might know and you might know that group work is also important for that. Right, so that's the first tool. And other places that this tool has been used with great effect is it really helped me and Max Blackie understand the Science Must Fall video clip and what's happening there and get a much better understanding for decolonization through that and the calls for it. It helped a large research group led by Chris Winberg understand something about how we in professional development can better interact with STEM academics in the area of professional development. And we also used it in the Science Teaching and Learning Hub at Stellenbosch University to consider which of our activities might be more effective than others in the area of professional development. All right, then I want to introduce you to another tool. This would be the last one for today, I promise. And this tool, again, about legitimacy, but now it's legitimacy sort of content and purposes inside a knowledge practice. So here we usually talk about a target, and the target is what you're after. Inside the target, you'd have target, or let me start this way. Autonomy asks two questions. Whose content is this, and for whose purposes is it being applied? And the target is where we would say we have inside content applied for inside purposes. In the mind of the science student, the inside target while they're studying would be science content for the purposes of understanding or learning science, right? That would be the content they're after and the purpose they're after. So now you can see that if that's their content and purpose, what they see as target, when I come and I teach about content from outside that target, I teach about group work and being an amenable human being, or how to handle conflict. I didn't talk about being an amenable human being. I'm just lying. But when I bring in group work content for the purpose of them being able to work in groups, they can't see the relevance to what they're doing at all. It's not target purpose. It's not target content. This helps us understand that we then need to put something else in place here so that they can understand that this is part of the defined target here. And that might require a whole lot of other work, but it does give a better understanding of why we might be struggling, and lots of us might be struggling with classroom control in that specific setting. All right, so where's this been used? I've got the wrong publication picture up here, but Mags and I use this to help us understand that there are some things that we might think might be examples of decolonization that might be interpreted rather as misappropriation, amongst others. And for DLSUP and I used it to look at teaching methods that would be to see if we can identify which methods might be better at helping students learn problem solving in physiology. Drawing it to a conclusion, so what? Some of us, maybe hopefully none of you, have received this kind of feedback on papers. It's an interesting paper, but not sufficiently theoretical. People always ask me, what does this mean? As a reviewer, I have a sense that it means the following. It means that this paper presents data, and it's probably looked at this data and disaggregated the data or looked at trends in the data, and it's presenting that data analysis as findings. But what the reviewer wants is that you bring a theoretical framework or a theory to make sense of those findings. So like I had the observation that students are now not paying attention, and that's my data. My theoretical framework is LCT autonomy that helps me understand, it helps me make sense of the data. And there's not much data to make sense of there. So we can say that the data is this pink line at the bottom of the semantic profile. The theoretical framework is a green line at the top. We can see there's a big disconnect, and we need some scaffolding. We need ladders to get up and down, to go from theory to data and back to theory. This is where LCT then is very useful, offering a tool called a translation device. And we use that with other theories as well. LCT just makes it more explicit and more accessible for us to understand how to put together a translation device, this thing that will help us link theory to data and data back to theory. So LCT, what does LCT offer? Starting with that and then drawing it all the way out. So it helps us in that zooming in and out, going from theory to data and back to theory in ways that I have tried to illustrate here, and specifically by offering a translation device, which I've not shown. That would be next level presentation. It's far easier than it looks. And it then offers us something which scientists really like, and I think this is why LCT is so popular in science contexts. It offers explanatory power. It offers a way of saying we think this is why this is happening, or we think we now better understand what might be going on. Not always causal, just trying to make sense. I think another reason is LCT just has a similar epistemology to science, but I could be wrong there. So drawing this all to conclusion, why are tools like LCT, because this is not the only tool, it's just one tool of many, useful? Because that helps us to build knowledge around teaching and learning and to abstract that knowledge into principles, which then allows us to make that knowledge travel. in the same way that epistemology, very abstracted, but we've seen epistemology travel from physiology to teaching and learning research. And recently I saw a YouTube video on epistemology in journalism. So when things are sufficiently abstracted, it builds knowledge that we can apply or take to other contexts and give meaning there as well. So that's really why we get that feedback to ask, it's not sufficiently theoretical. But Anthea, this is me. I think I can go to the last slide. There we go. And I'll put up a last question in the chat, just because I want to know what tools you guys have played with.
Thank you so much, Hanli. Really amazing presentation. So if the audience could just perhaps respond to the last question that Hanli has put up. She's posted that in the chat. What tools have you used or found useful for making sense of teaching?
And while people are responding, I've shown you 3 of LCT's tools there. There are quite a few more, but I think this gives a sufficient idea of what the theory can do and does. So here, any theory, it doesn't have to be LCT. I'm just curious as to what tools you normally work with. So any theory that, there we go, collaborative learning. But yeah, please feel free, as Anthea said, I'll shut up, Anthea, to pose or post your questions.
All right, while audience members are still posting their responses, I see there are interesting responses such as constructive alignment, action research, images, that's an interesting one, visual tools, links to that one, cognitive apprenticeship, that one is a new one for me. Teamwork. Interesting responses thus far. So thanks very much to the audience for being such an engaging audience, and also to you, Hanali. Thanks so very much for taking the time to share your ideas around LCT with us. Let us show our appreciation to Hanali. Perhaps if you could use the hand clap icon. Thanks so much. My screen is being flooded with all sorts of icons to show appreciation. So we will now have a question and answer session, and you are welcome to put up your hand, raise your hand if you have any questions that you would like to pose to Hanali. I also just want to make sure that Mohammed is in the audience. Mohammed, are you there? If you could also, right, if you could also just assist in managing the questions. Right. Anyone who would like to go first? There's no one who would like to go first. Perhaps a question from me, Hanali. Oh, there, Annika Venter. You're welcome to go ahead.
Hi, thank you. I'm just interested to know what you did with that large group of students and the group work, where you couldn't control the room. What did you apply, and how did it work out?
So, Annika, I presume you don't want to know all the failed attempts, which I'm really shy about. At one point in time, I told them that. I can't even remember. I can't remember that. That's how shy I am. But I know I tried really punitive measures. They'd lose marks. They'd be asked to leave the classroom. And then I would stop teaching. But what we did in the end, and then COVID happened. Have any of you had that story? You know, all sorts of great ideas, and then COVID happened. Is we started playing with the idea of actually packaging the principle, because all we wanted to do is they had to do a group work project in this module. It's a module that they already didn't see as very important. It's called University Practice, so it's intro to all sorts of stuff at university, which was offered in the ECP course at Stellenbosch University. So all we wanted to do was enable them not to get stuck in the group work, not to get stuck on conflict and all sorts of stuff like that. I was at the same point in time working with an academic, quite the opposite end of the spectrum, in agri-sciences, in food science, she had a project module. So she had fourth year students who had to, in groups, develop a new food science product according to certain criteria and rules. And they also had to work in groups for a whole year. And I learned a lot from interacting with her, where we offered similar lectures to what we did in the first year. So in that case, also initially, let me put it, students really needed to work in groups to make it work and to pass the module. There was no other way. So there was a more urgent need, but we offered the group work quite early. We learned two important things from that, which I'll share in a moment. But what we then came up with from that one is what we're trying to do is just help them, teach them the principles of how would you handle conflict, what are other ways of doing things, how do you set ground rules in a group. And the idea we've been playing with but didn't get to implement was to package that into a game. It could be a board game, which is what we originally had in mind. There are interesting board games that require cooperation for you to have success in the game. Forbidden Island, for example. So we try to build a game sort of on that premise. But then, you know, you can't play a board game if you've got to be 1.5 meters from your colleagues. So that we've never tested. I'd like to do it in future. But the one important thing we learned from her work was that when we taught chemistry, we had chemistry tutorials where I was there and I had tutors that helped students understand chemistry concepts. But when we have group work as an outcome, we don't have tutors, and we don't fill that role of helping them work through the group work issues, how to make sense of that. And she did that with her students, and she had amazing success with group work, but it was also very, very time intensive, which is why we then thought if we could find another way to package it. But that's an ongoing project.
Thank you, Hanli. Thanks for that response. Annika is giving a thumbs up. So thank you very much for your response in that regard. Any other questions? Perhaps, Hanli, if I, from my side, if I could pose a question, you know, quite often I do a lot of work in one of our faculties as well, in the Faculty of Education, and quite often one gets the question, how do you go about trying to narrow the gap between theory and practice, because quite often students just don't get it. And you mentioned the translation device. So do you perhaps have any further explanations for us of how specifically the translation device could be beneficial, maybe perhaps link it to an example from social sciences?
Yeah, that would actually be useful. I'm thinking now, I was thinking as I'm talking, it would have been useful if I had an additional slide with but I can talk it through. So again, if we take, for me, it was an interesting exercise taking the epistemology example. I'm also trying to think, we did that with decolonization, but that's a lot of years ago. What we would do in a translation device is we would just draw a table. And on the table, what I would do is in the left-hand side column, I would plot from, let's say I'm taking gravity, for example. So least gravity, most abstracted, would be the very top row on the table. Then I'd have a row one level down. That would be something that is still abstracted, but it's maybe more in the example state, so it's not as abstracted. I'm going to go back a few slides to the epistemology example, and then from there try and give an idea of what it would look like. There we go. So my top row in the table would be, the way we work in LCT is semantic gravity's depictor would be SG for semantic gravity, and SG minus would mean least gravity, most abstracted, most up there in the air. And SG++ would mean closest to the ground, so most semantic gravity. It feels wrong, it's upside down, but it makes sense. And then in between, normally we plot two more levels, SG+. So it's it's not as close to the ground, but it's also not abstracted, and then SG minus. So we just plot that scale, a gradient from closest to the ground, one step up until most abstracted. And then it's a matter of thinking about the thing you're dealing with and trying to figure out. So that's then where we do the cognitive work. Then you go in and say, okay, right at the top, and LCT has lots of interesting information on how people has applied this, and you can unpack this in far more detail, which Manel Matan has done, and more decent papers on semantic density, for example. Christina Steenkamp, that example I showed from physics, they only looked at gravity. So they only looked at how abstracted or not examples were, and applying a few more things there. So then I would go and I would say, in my data, in teaching epistemology, in the content I'm working with, what would the most abstracted version of this would look like? So the most abstracted version would be that it is it's epistemology. It's sitting right up there at the top. What would the most contextual version look like? Well, maybe something like experiment right at the bottom, and then I'll fill in between. So objectivist is an example of an epistemology, but it's still quite abstracted. So that would go in the second level from the top, and then maybe something like observation. These could be the 4 levels: epistemology at the top, then objectivist, and then I'll try and make sense of it. And I'll say, okay, so this is an example of that thing. So one level down, I'm looking for examples. Another level down, I'm looking for maybe approaches to data gathering. And then right at the bottom, I'm looking at specific methods of data gathering or specific research approaches. And that would then become my translation device. And now when I go back to data, I'm saying, oh, this is an example of, so it's sitting on that level. And when I do research, then typically that's how we would do the coding. I think previously I shared my difficulty in just understanding what coding was, when that was how steep the discourse access entry was for me initially. I couldn't figure out what coding was. So we would then take that back to data and say, and that's what Christina and them would have done, physics example, but I'm going to use this example now. They would have said, oh, so everything that is in that very abstracted conceptual state, like epistemology concept, that is level 1. We don't want that much of that in the test, because that's really high level. One level down, all the examples, that's level 2. Another level down, all the approaches, that's level 3. And then specific methods or studies or whatever it was, lowest level. I don't know, Anthea, if that helps at all.
No, it does help. Thank you. Thanks so much, Hanli. Thanks for unpacking that question. I'm now going to invite, I think we have time perhaps for one more question. I'm now going to invite Salosh just to unmute her mic and pose her question. She posted a question in the chat, but I think it would be better if she poses a question herself. Over to you, Salosh.
Thanks, Anthea, and good day, colleagues. I've just been coming from a workshop now where we are assisting academics at UNISA on how to facilitate, how to teach the students online. And I just want to find out if, what are your thoughts on student-led lessons? And do you have any strategies on how we can promote student-led lessons in an online environment?
Yeah, it's an amazing question. As you can see, I love audience participation and seeing what people are doing, and I have played, but never in the online space, with student-led work. So I think it is definitely a topic worthy of pursuing. And one of the big reasons for it is we know that old axiom of, when I teach it, I know it. So I always think that if students get the opportunity to lead and to take responsibility and to grapple with something like this, it can really help them make sense of it. I think from my own personal experience of doing it in face-to-face a long time ago, though, is something that people put up there in my questions earlier is the importance of instructions and guidance, what you want and guiding them, and taking away the fear for them as well, helping them, even if they have an opportunity to run their plan by you a little earlier, just talk it through to see if they're on the right level. That could be really useful. Beyond that, two things, and people are not always agreeing on this. Sometimes we find that students relate quite well to other students because they know what they're struggling with. So that helps us see what they're struggling with, and they speak their language more. So that's been generally an experience. Some people have experienced, but that's more with assessment and peer assessment, that they don't always trust their peers. But I think if it's student-led, but with facilitators still in that process, so that they don't feel they left alone. The biggest argument we get against this, again in face-to-face space, is when they start thinking that it was the facilitator who was too lazy to do the work. So having them understand why this is part of the module and how it would benefit them. But that's just off the top of my head and not based on recently read theory. Maybe other people have, maybe other people have more recent experience in the audience. Either if there is someone, please put up a hand and help us out here. And then I see Yolandi Yulani is asking what would be the purpose. I think that's a good starting point as well, to ask yourself, what's the purpose, and have students understand that.
Solange, you happy?
Yeah, thank you. Yes. I just want to add that, at UNISA, for example, in an online context, we get a lot of students who are currently in the workplace, but they are working towards their qualification. And I'm thinking that if we encourage student-led lessons, student-led discussions, they will bring in a lot of informal kind of learning into the situation. And this is what we should also focus on and pay attention to, the informal learning, the importance of the informal learning from a student perspective.
And personal experience, and how they, they're often in a better position, depending on what it is that they're studying, to relate the theoretical stuff we bring to practice. I'll share briefly from a personal example. My husband's in construction. And a few years ago, he attended a single part of an engineering course offered at Stellenbosch on the contract that they all use. It's JCC something, I can't remember all the letters. But that's the contract that everybody in construction uses. So it was updates to that and how it works and how to interpret it. And he said to him it was so valuable because he's in practice and he knows what they're dealing with. So he had the opportunity to ask questions of the lecturer. And I mean, they could present their issues and their problems. They didn't. But I'm thinking now in the student-led environment, you could ask them to present on it. The interesting experience he had is that the students who were enrolled here as just out of school got very upset with the people from practice that kept asking questions. I think that's very, very valuable to see how this thing plays out and to be able to bring that informal learning into the classroom.
Thank you. Thanks so much to all the questions posted, and also for your responses, Hanli. Unfortunately, colleagues, we've run out of time. We would have loved to further engage on this topic, and I would suggest that you keep on posting your questions in the chat. Perhaps we can respond to that afterwards. But thanks so much for a lively engagement and for an interactive presentation. Thank you, Hanli. It was really amazing. I think if there's one thing that I take away from this presentation is when you spoke about specialization and you referred to the social relations. With everything changing in higher education and in our context, that is increasingly becoming more important, and how we build relationships with our students also as a way of getting the knowledge through to them. So that is the one thing I take from this amazing presentation. So thanks everyone. Thanks for being here. Thanks for making the time to attend this webinar, and to you, Hanli, from the bottom of our hearts, thanks for your time as well. Thanks, everyone. This recording will be available, and it will be posted on the HELTASA website as well. So have a good afternoon further. Take care, everyone. Thank you.
Thanks, everyone. It was a pleasure, Anthea.
Thanks. Bye-bye.
Thanks. Bye.